The stage is set for the most requested feature in C# over the past decade, discriminated unions. We have everything we need to use them. We have record types to model state, we have extension members to model behavior, including static factory methods we can attach to a type. We have switch expressions with great support for pattern matching, property patterns and everything. Everything is there. Are you there? Are you using these modern elements of C# to model your domains? Please join me in this demo. I will first show you how the application runs. It is a very small application that takes some estimates of work in, say, software project, and then organizes the work and estimates when the entire feature will be completed. Take a peek at this record type. It is a central type in this application, the work item. A work item has a name, a time span, which is its estimate, and a list of prerequisites. Now, the scheduling algorithm works like this. It takes all the prerequisites, waits for them to complete, and then takes the new work item into consideration. The problem I have with this model is in this use of the time span. Not every work item has just a span as its estimate, and that is the candidate for a discriminated union. This is how discriminated unions work. First, name the concept. We are modeling an estimate, and then list all the possibilities. An estimate can be a duration. That is what we already had, just a time span. It could also be an interval from 2. And the most difficult situation, it could be unknown. We are waiting for something to happen. We cannot tell when the feature will be done. What makes this bunch of records a discriminated union? There are several elements you need to satisfy. First, each variant here is an estimate. A derived class or an interface implementation will work just fine in C#. Second, there is no such thing as the estimate. An estimate is an abstract type, either an abstract record or an interface. The third rule is that beyond these 3 variants, there is nothing else. We still cannot model that entirely in C#, but we can help a bit by making all the concrete records sealed so that at least they cannot have other derived records. Once proper discriminated unions come to C#, they will look pretty much like this, only with a few words removed from this source code. The syntax will be a bit stripped down and more efficient than what I did here, but the substance will remain the same. And then comes another specific feature of discriminated unions. An entire union behaves as a single type. There are no intervals or unknowns or anything. There's just an estimate. For example, there will be the factories, static factories for each of the variants, but unlike common constructors or common factory methods, the discriminated union factories will all return the discriminated union type. Constructors cannot do this. Constructors cannot return something else. Also, factory methods are a great place for validation. I would really need to implement smart constructors here, not to throw, but that is a more complicated and longer topic, which I will unfortunately not touch in this video. I will stay with traditional throw instructions here. This completes the definition of the discriminated union, and I can use it to complete the design. Instead of using a time span, I will use an estimate. Even without the behavior, you can accomplish a lot with just the data definition. This collection of work items really makes sense. You will gather requirements, design the API, design the database, complete with the deployment and the completion of the entire feature. These are the work items I want to schedule. This software will schedule work, helping project managers, I suppose. Which brings us to the last element of discriminated unions: behavior. We need to estimate the combination of estimates. We do that in the form of an extension method, but look, an extension method attached to the root type estimate, not to any of the variants. Any behavior operates on the entire discriminated union, not on just one variant of it. And let me show you how that works. We can add another estimate to the existing one, which literally means that we will complete one task and then move on to another. That is where pattern matching comes to the table. And pattern matching in the modern C# is implemented in the form of switch expressions, not switch instructions. I am mapping the estimate and the other estimate, and then checking what they are. The type test and set is a valid pattern. If both are the durations, then I just add their values up. Otherwise, if one is the duration and the other is interval, then the lower estimate of the interval will move by the duration, but its span will remain. Finally, if both are intervals, then their lower estimates add up and their spans also add up, making a higher and wider estimating interval in the end. The last default possibility is that one or both estimates on the input are unknown. In that case, we cannot tell anything, the result is also unknown. This is a typical implementation of an operation attached to an entire discriminated union. Let's raise the bar. We need one more operation. Some tasks will operate in parallel. I will add a few helper methods to pull out the optimistic and pessimistic time from any estimate. One more helper method will combine two nullable estimates, optimistic and pessimistic one, into an estimate object. But look what I can do now. I can use one wonderful feature of switch expressions. I can match a nullable value object such as a time span, a nullable time span, with the empty curly braces. This pattern will only be matched when there is a value inside a nullable value object, and it will also pull out the value from it into a variable where I can capture the existing time. Fun fact, everything I wrote so far are the switch expressions. I will also need one more extension method. The patterns are very similar to what we had above. You can now attach private extension methods and use them only inside this class, just as I'm going to do in the implementation of this last method in parallel with. We'll construct the estimate from nullable timestamps, where the lower estimate is the maximum of the two optimistic estimates, and the higher estimate is the maximum of the two pessimistic estimates out of the two objects. The composition of functions applied on top of the whole bunch of switch expressions. That is what software development looks like when all you have is immutable records. Let's move on to implementing behavior on the work items, because that is what the ultimate request in this software is. We need to estimate the completion of a work item. A work item that has no prerequisites only has its own estimate. However, when there are prerequisites, we need to estimate each of them individually and then to aggregate them using the parallel aggregation of estimates, because all the prerequisites will theoretically run in parallel. Finally, when all the prerequisites are done and combined together into a single estimate object, you just add this work item's own estimate after all the prerequisites. Let me show you what these functions can do. This is the program.cs. It is effectively a UI, and what UI does is to format data into string representation or to choose a sort order. These are just helper functions. Now comes the central element. I need to go at the top to include the behavior which I plan to invoke, and then it goes. We need completions of all the tasks, so let's start from the tasks. Then for each task, select its name and the estimate, sort them by the estimate using that sort order defined above. Iterate for these, write them out, and the application is complete. I will run it again so that you can see. Here it is. It prints out the estimates for all the work items in that set, sorted ascending by the completion, rounded up to days, and yet all the complexity in this small application is focused in this screen, where I'm just analyzing the types and the contents of discriminated union instances, combining smaller objects into larger ones, producing a fairly complex result of a complex operation. I hope you will find ways to implement models like this one in your applications too.